All right, welcome back. So we're going to jump into lesson 4.3 today, which is greatest common factor. Greatest common factor is also known as GCF. Taking the first letters of these three words, GCF, greatest common factor, section 4.3. So let's list the factors of these two numbers. Let's list the prime factors of these two numbers. So you will have got this lesson in 4.2. So listing the prime factors, we're going to break these down into their pieces. So 2 goes into 12 6 times. 6 is broken down into 2 and 3. So the prime factors of 12 are 2 times 2 times 3. Do the same with 18. 2 goes into 18 9 times, and then 3 goes into 9 3 times. So the prime factors of 18 are 3 times 3 times 2. Now when we compare these two lists, if we look at these two lists here, we're going to circle the ones that are in common. So this one has a 2 and this one has a 2. So we're going to list the 2 once, only once. And because the right one only has 1 2, we can only list it once. And we have a 3 on the left and we have a 3 on the right. So we're going to list the 3. And at that point, we don't have any more common numbers between the two sides. So we're going to go ahead and stop, but we're going to go ahead and multiply 2 times 3, and 6 is the greatest common factor between 12 and 18. So 12 is divisible by 6, and 18 is divisible by 6, and 6 is the greatest common factor. All right, let's take a look at some more. More examples. So these are a little bigger numbers, 24 and 36. So let's do the prime factorization, breaking it down into the two numbers that are divisible until we get down to prime numbers. Again, you can kind of start this however you want to, so long as you pick two numbers that go into the number above it. All right, so 24 can be written as 2 times 2 times 2 times 3, and 36 can be written as 2 times 2 times 3 times 3. Okay, so we are going to circle the ones that appear in both lists. There's a 2, there's another 2, and there's a 3. Okay, now we've run out of common numbers, so we're just going to multiply these three numbers together. 2 times 2 is 4, 4 times 3 is 12. So 12 is our greatest common factor. 12 goes into 24, and 12 goes into 36. Okay, let's do a couple numbers that are bigger. Let's do 180 and 600. So we're just going to, both of these numbers are easily divisible by 2. So again, just keep going until you get down to the prime numbers. Okay, so we're done with 180. Let's do the same with 600. I'm going to do 60 and 10. So 10 is 2 times 5, 60 is 6 times 10, and again 10 is 2 times 5. So rounding up all the prime numbers, we got 2 2s, 2 5s, and a 6. Oops, the 6 can be broken down into 2 times 3. So let's add another 2. Let's put a 3 in the mix, replacing the 6 with a 3 and a 2. All right, so let's list the factors of 180 again here at the bottom. Now this time I didn't go in order, but we can still collect the number of duplicates. So there's a 2 here and a 2 here, so we're going to write 2. There's a 2 here and a 2 here, so we're going to write 2 again. Let's see, 5 appears in both lists. At least one 5 appears in both lists. There's a 3 here and a 3 here. So we're going to write a 3 down. Now the rest of the numbers are not duplicates. So we can't write any more numbers. So to get the greatest common factor, we're just going to multiply 4. You can either go 4 times 5 times 3, which is 20 times 3, which is 60. So 60 is the greatest common factor of these two numbers above. So 60 goes into 180 and 60 goes into 600. Okay? And 60 is the biggest number that goes into both of them. All right, so in your homework, basically, you're asked in the first 12 problems to find the greatest common factor of each of the pairs. That's what we just did. Numbers 13 through 21 give you, sometimes they'll give you 3 numbers, so maybe we should do one with 3 numbers, but it's pretty much the same thing. So let's take number 20, for example. In number 20, we're given 27, 45, and 54. So you need to know your multiplication tables to do this quickly and efficiently. 3 times 9 is 27, and 9 is 3 times 3. 45 can be written as 5 times 9, and again 9 is 3 times 3, and then this could be 6 times 9. So 2 times 3 is 6, and 3 times 3 is 9. So we have our prime factors now. 27 is 3 times 3 times 3. 45 is 3 times 3 times 5. And 54 is 2 times 3 times 3 times 3. 3 threes. Okay, so circling the numbers that appear in both lists. We have a 3 in both lists. Let's see, we have a 3 here. We can do another 3. There's a 3, there's a 3, and there's a 3. And I think we've run out of common numbers because we have a 5, a 3, and a 3 left. There's not one number that's common to all 3 of them, so we're going to have to stop there. So the greatest common factor for these 3 numbers is 9. So 9 goes into 27, 9 goes into 45, and 9 goes into 54. That's the biggest number that goes into all 3. Okay? In the last set of problems, it asks 31 through 36. It gives you the prime factors, and it gives you 2 sets of prime factors. So these are numbers that have been broken down into their prime factors for you. So that saves you some work here. So the first number is 2 times 2 times 3 times 5 times 5. Remember, the square just means that you have 2 5s. And then we also have another number that has 2 squared, 5 squared, and then a 7. So clearly the 7 is not common to both. And there's a 3 over here in the left one that's not common to both. So the 3 and the 7 are going to be excluded. These are repeated. So we got 2 times 2, or if you would, 2 squared. We list 2 squared once. And then 5 squared is also in both lists, so we can also include it. So 2 squared is 4, and 5 squared is 25. So the answer here is 4 times 25, which is 100. So 100 is the greatest common factor to these 2 numbers. Okay? Let's talk a little bit what happens when we have letters. For example, number 23. 23 in the book has a list of letters and numbers. So 9, C to the 3rd, D to the 5th. And then the other number that we're looking for commonality is 12, C to the 4th, D to the 4th. All right, so if we broke these numbers down, we get 3 times 3. 12 is 3 times 4, and 4 is 2 times 2. So looking for commonality, there's a 3 that appears in both lists, and that's about it. That's about it. So 3 is the number that's in common. Now when we look at the letters, c to the third is c times c times c. And c to the fourth is 4 c's multiplied. C times c times c times c. Well, we can get up to 3, but no more than 3 that are in common. That fourth one is not, there's not enough c's on the left one to allow us to grab 4 c's in common. There's only 3 c's in common. So what we've learned is if you'll take the, if there are c's in both lists, you take the exponent of the one that has the least and you write it down here. That's the number that they have in common. So likewise, if we'll look here to the right, the D has 4 and the D has 5, so we can only put D to the fourth. That's as many as they have in common. So this is actually the greatest common factor for these two numbers, or these two expressions that include numbers and letters. So it's 3, c to the third, d to the fourth. All right, that's all I got. Thanks for watching.